Hey guys, so in the previous video we talked about sequences and we knew that there were two types, arithmetic and geometric. So today we're going to be focusing on arithmetic sequences. So arithmetic and geometric have something called explicit and recursive formulas. And in this video we're going to be talking about arithmetic sequences and their explicit and recursive formulas. So to get started, explicit or the closed formula for the arithmetic sequence has this formula: a sub n equals a sub 1 plus n minus 1 times d. What I like to do is just put the d before the parentheses. That way, like, you'll see why I preferred that in a moment, but it doesn't matter. You can put it where at the beginning or at the end, but I personally prefer to put it in front of the parentheses. So let me explain what these terms are again. If you haven't watched my previous video about the introduction, you should go ahead and do that. But anyways, let's go ahead and talk about what these terms are. So a sub n is just your y value. It is your term value. A sub n, this is your first term. So this is your first term. First term. D is your common difference or your slope. And then n is your x value slash the term like number. And then minus 1. That's it. So this is our explicit formula for the arithmetic sequence. Let's go ahead and write the recursive formula, and then I'll talk through how we would put this in a sequence. So recursive, you have kind of two parts. So you have a sub 1 equals, a sub 1 equals, and that's your first part. Pretty straightforward. You're just writing down the first term. And then for your second part, you have a sub n equals a sub n minus 1. This whole thing is in a subscript plus d. So going over what these terms are, this is your first term. First term. And then a sub n, this is your y. This is your previous term. Previous term. And d, again, is your common difference or your slope. Difference. Perfect. Now that we have both the recursive and explicit formulas written out, let's go ahead and see how we'd put a sequence into these formulas. So we have a problem right here that says write an explicit and recursive form for the following sequence: 13, 18, 23, 28. The first thing I like to do is figure out what my common difference is, or the slope, like by what number are these numbers increasing by. So 13 to 18, that is a plus 5 increase. Then 18 to 23, another plus 5. 23 to 28, another plus 5. So we can clearly see that the difference between each number is 5. Let's say it was more complicated, like you had bigger numbers. All you need to do is subtract the next number with the previous number. So 18 minus 3, that gives us 5. 23 minus 18, that gives us 5. So that way you can figure out what this number is if you can't see it straight away. Okay, now that we have our common difference, so this 5 is our common difference. I'm just going to write D. We have our D. The next thing we need is our ace of 1 value. That's over here. This is our ace, the first term in our sequence. So we have that as well. We don't need to write y and x because if you guys remember the slope formula, it's just y equals mx plus b. We have a number for m and b when we write the general form. So we're not gonna, we don't need a number for the ace of n. So that's all sorted out. And then n is like our x. Again, that's also sorted out. So we're good. So for our explicit formula, all we're going to write is, let's choose a different color here. Let's say green. Okay, so ace of n equals our first term, which is 13, plus d, which is 5, positive 5, times n minus 1. So this is my explicit formula for this sequence. Now for the recursive formula, I choose a different color here. My first term, again, is the same, 13. And then ace of n, again, we don't write the y and x so in our slope formula, so we don't have to write it here either. So, we don't have to state that value here. The previous term, ace of n minus 1 plus d. So for this part, all we need to do is just write ace of n minus 1, again, still in the subscript, plus 5. So notice that they're the exact same thing. Like the only information you need for both of them are your common difference and your first term. And then your n minus 1, which is kind of saying your previous term, which is available in both forms. So those are your explicit and recursive formulas for the arithmetic sequence.